Good afternoon everyone, we are a student of electrical department. Today we are making this video to give a short presentation on our final year project as our college is started. We have made this video in such a way that anybody watching this video anywhere from the YouTube, they will clearly understand our working idea, and after watching this video you will completely understand
what auto intensity control of street light means and why we need auto intensity control of street light.
We also talk about our main working idea and working principle of our project. Also, we're going to discuss about the basic idea about the components that we have used throughout our working model.
So watch this video till the end and do let us know your feedback in the comment section.
So let us understand that what is auto intensity control of street light means. It means the intensity of street light controlled automatically based on the sunlight condition and traffic density. But the most interesting thing is we don't have to turn on and off it manually.
So why do we need this auto intensity controlling street lights? Being an electrical engineer, we always want to design a system which operates on high efficiency. Street lights on the roads are man-operated and manually controlled. Now they are turned on during the evenings and continues to glow till the morning.
This results in unnecessary uses of power as because they keep glowing at fuller intensities all the times. But this is not necessary when there is no traffic or in the morning or in twilight time. So when there is no necessity, we can reduce the intensity of those street lights and we can turn off the lights. And in this way, we can save a lot of energy.
The main working ideas of our project is to control the intensity of street light, for which we are using LDR sensors, IR sensors and Arduino. Let us first see the descriptions of these components, why we are using this and what they do.
We will not go in detail, otherwise size of the video will increase. We just wanted to give you a basic idea about all the main components which we have used in our working model. The component you can see here is Arduino board. I can show you the practical one as well. This is the brain of our working model. It can read digital and analog input and process into output such as activating motor, turning on LED, even publishing something online. You can tell your board what to do just by giving some instruction in his language, very similar to C programming, or rather I would say it is a bit easier than C programming.
The next component is LDR. It is a variable resistor whose value changes depending upon the intensity of ambient light. So we can use it to sense ambient light through microcontroller.
The next component, as you can see here, is infrared sensor. Infrared sensor senses an object by emitting infrared light. There are two different colored small LED light, as you can see here. One is transmitter which emit infrared light, another one is receiver which will receive light if any object is detected. We will be using this component to sense traffic density in our model.
Now we are going to discuss about our main working principle. Here we are using LDR or light dependent resistance, which changes its value of resistance as per the ambient light. Arduino or microcontroller is going to calculate this resistance and tell us about the intensity of the ambient light. After this, as per the program, the Arduino now decides that how much light the street lights should emit in order to balance this absent ambience. After this calculation, the LED light intensity will be controlled as per the following algorithm that we have programmed in the Arduino or microcontroller.
The first and last street light will be set to the required intensity of LDR. The intermediate light intensity will be changed as per traffic density, which we will sense by IR sensor.
Once a car moves to the second street light, the street light will be turned on with the required intensity of LDR. And the same will be followed for the third street light also. Then the car moves to the third street light, and the third and the fourth street light, both street light will be turned on with the required intensity. And the remaining street lights except first and last will be turned off. And the process will continue as the car moves through the road.
We have made the algorithm by taking the following points into consideration in order to make the traffic driver to see the road. The first and last light will be turned on.
Energy consumption will be reduced by changing the light intensity of intermediate light. When road traffic is less, light will glow at lesser intensity, so a city's view of the town will improve. This is how our microcontroller controls the intensity of the street light.
So here we are getting a 0 to 5 volt PWM signal from our microcontroller, but in real case we need to control higher voltage rating, typically 220 volt AC street lights. So we need to change, or we need to vary the AC voltage in order to change the intensity of street lights.
Controlling a high voltage device from low voltage signal always requires drive. There we need a variable AC drive. This can be made of using triac, transistor and other power electronic switch, but there we are getting only 37% of efficiency. To improve the efficiency, more switches has to be used, which resulting increase in harmonic. The problem is not there when we are using variable resistor in our circuit. This is around 78% efficient. It is built like a fan regulator which we use in our home to control the speed of fan.
But if we want to control the potentiometer automatically, then we need something that will rotate the shaft of the pot in place of human hand. So the solution is 5 volt servo motors. These small servo motors can be driven by microcontroller 5 volt signals. If we mechanically join the shaft of the servo motor with the shaft of the potentiometer, then the shaft of the potentiometer can be rotated by microcontroller signal, resulting in change of AC voltage at the output, hence controlling the intensity of street lights. Another facility of this driver is it is completely galvanically isolated, because there is no electrical connection between low voltage and high voltage side. So this is just what we need. We made a driver having high efficiency. So from all sides, this driver is ideal for this project.
In this project, we are using IR sensor to sense traffic. Generally, IR sensors can sense up to 15 cm maximum. But in real, the streets can be wide up to 100 meters. So we have to think of an alternative in this case. Thermal sensors can be a good solution in this case.
But why, when we have satellites? There is a technique called image recognition. Have you ever been in online cab? If yes, you must be familiar with red, blue or yellow lines in this app. These lines are the results of image recognition of traffic density images taken from satellites. We can use this data in our project. Latitude, longitude of zones having higher traffic densities will be sent to the microcontroller via a GSM module. The microcontrollers then send the sets of values of intensity as per latitude and longitude.
So in this way we can make a highly efficient auto intensity control in street light. Express our heartfelt thanks to Mr. Sumanta Das, HOD of Electrical Department CIM, for his valuable guidance and encouragement during our project. We are particularly thankful to Mr. Sandeep Sarkar, Project Guide and Assistant Professional of Electrical Department, for his guidance and giving us permission to undergo this project and providing all the necessary facility, intense support and encouragement which help us to model our project into successful one. During our project period, all the staff members of Electrical Department have helped us with their skills. Finally, thanks to all our friends for their continuous support and help. Thank you.